Welcome back. In this video, we'll be looking at expanding double brackets. In our previous video, we looked at expanding single brackets. Expanding double brackets is an extension of expanding single brackets because the principles are the same. We multiply everything on the outside of the bracket to the right with all of the terms in that bracket. So let's remind ourselves what's expanding brackets. Expanding means to remove brackets using an appropriate method, preferably either algebraic or numeric. Simplifying expressions means that we collect like terms. So let's have a look at 4 examples to start off with. X plus 2 times x plus 3. We can think of this as x lots of x plus x lots of 3. So that is x times x plus 3 plus 2 lots of x's plus 2 times 3. So plus 2 lots of x plus 3. By expanding each of the single brackets, you should have obtained x squared plus 3x for the first one and 2x plus 6 for the second one. Now if we look carefully, our x terms are like terms because they have the same letters and the same powers on the letters. So we can combine them by adding them together, which results in a 5x. So the first example simplifies to x squared plus 5x plus 6. Let's have a look at the second example. We've got 2x minus 1, lots of 3x plus 4. So we do the same. We take the 2x and multiply it to the 3x and the 4. So that is 2x times 3x plus 4. But here we've got a negative 1. Now, at all times, we should be taking into account the signs in front of every single term in all of our brackets. So we're going to do negative 1 times 3x plus negative 1 times 4. And we can write that as just simply negative brackets 3x plus 4. Note in algebra, we never ever write a 1 or negative 1 in front of a bracket. We just put the sign in front of the bracket. So expanding the single brackets results in 6x squared plus 8x, followed by minus 3x minus 4. And again, the x terms are like terms, so we can combine them by subtraction due to the signs, and that gives us 6x squared plus 5x minus 4. What about this third and fourth example? We have x plus 5 brackets squared, followed by a 2x minus 1 brackets squared. In this case, we have something called a completed square. We'll have a look at the completed square in the next part in more detail. So what is that exactly a completed square? Well, it is an expression of the form of either x plus a or x minus a, where x and a can be any expression, but having brackets around it and a squared around it. So this means that we can rewrite it using our knowledge of squared terms. If we are squaring a term, it means we're multiplying that term by itself. The same applies to expressions, since an expression is a collection of terms joined together using our 4 basic operations. So let's have a look at what's going on here. So x plus 5 brackets squared can be rewritten as x plus 5 times x plus 5. So now we've got double brackets. And how do we expand double brackets? First term of the first bracket multiplied to all of the terms in the second bracket, plus the second term in the first bracket times all of the terms in the second bracket. So x lots of x plus 5 plus 5 lots of x plus 5. That simplifies to x squared plus 5x plus 5x plus 25. So 5x and 5x are x terms are like terms, and we can combine them by adding them together. So that gives us x squared plus 10x plus 25. How about example number 4? We do the same. We rewrite that as 2x minus 1 times 2x minus 1. To expand that, we're going to do 2x times 2x plus 2x times minus 1 plus minus 1 times 2x plus minus 1 times minus 1. So that's 2x lots of 2x minus 1 minus bracket 2x minus 1. Because we never write the negative 1 or positive 1 in front of a bracket. And that becomes 4x squared minus 2x plus 1. The x terms are the like terms, so we can combine them, and that gives us 4x squared minus 4x plus 1. Have a look at examples 3 and 4 carefully. What do you notice? Well, what you should have noticed is that we are squaring each of the terms in the brackets separately, taking into account the signs, but we're also multiplying the terms together and doubling the product. And that's where this middle term comes from. So a completed square is anything of the form a plus b squared or a minus b squared. And a and b, that could be any expression or constants. For example, we might have x minus 3 squared. You could also have something like this: x as y minus 1 squared. That's in this form because you can have x as y being a and the minus 1 being b, and etc. So as long as you can write it as single bracket squared, that works. There is a useful technique for expanding these, so let's have a look at it in general. So if we expanded a plus b, we know that's actually a plus b times itself, so it's double brackets again. So we're going to do a lots of the second bracket plus b lots of the second bracket. So that's going to be a squared plus ab plus ab plus b squared. And look, we've got the product of a and b, but we've got it twice. So that becomes a squared plus 2ab plus b squared. And the same applies to a minus b squared. That's a plus a minus b times a minus b. So what we end up having is, in fact, a lots of a minus b lots of a minus b. So that's going to become a squared minus ab plus b squared. So that's a squared plus b squared minus 2ab. In other words, a squared minus 2ab plus b squared. So use of these formulas will be a bit quicker. For example, if I was to do 3x plus 2 squared, I can straight away do 3x squared plus 2 lots of 3x times 2 plus 2 squared. And that will give me 9x squared plus 2 lots of 3x lots of 2. Well, we've got 2 times 2, which is 4, times 3x, which is 12x, plus 4. Isn't that a lot quicker? And we can do the same if we've got something like 2x minus 4 squared. So you do 2x squared in brackets minus 2 lots of 2x times times well, here this is where you have to be really careful. We are just dealing with it as if it's just A's and B's. So in this case, we need to take the B as a 4. Otherwise, you would end up with a positive term, and that is entirely incorrect. So we would have 4x squared, or minus 2 lots of 2x times 4. 2x times the 4 gives you 8x. 8x times 2 is 16x, and plus 16. So this makes it a lot faster. I'd like you to have a go at the following examples. Feel free to pause the video and have a go. Okay, I hope you had a go. Let's go through these. For the first one, you should have got the following: x lots of x plus 4 minus brackets x plus 4, and that gives you x squared plus 4x minus x minus 4, which simplifies to x squared plus 3x minus 4. Okay. Second one, you should have got 2x lots of 3x plus 5 plus 3 lots of 3x plus 5, and that simplifies to 6x squared plus 10x plus 6x plus 15. Whoops, sorry, plus 9x plus 15. Beg your pardon. 3 times 3x is 9x. So we would have 6x squared plus 19x plus 15. Okay. The final one, that is basically 2 minus 3x times 2 minus 3x. Now you're welcome to use the formula. So that will be 2 squared minus 2 lots of 2 lots of 3x plus 3x squared. So here we've got 4 minus 12x plus 9x squared. Now if you've written your answer as 9x squared minus 12x plus 4, that's also correct too. Okay. To finish off, let's look at some very unique examples. Here, what you'd notice is that the two brackets are nearly identical, but with a different signs. So we can say they are what we call conjugates of each other. When we multiply these out, we only have two terms in the expression, as you will see. And we call, though, this type of expression the difference of two squares. So let's have a look at why that is the case. We do x lots of x minus 1 plus 1 lots of x minus 1 for the first example. So x lots of x minus 1 plus 1 lots of x minus 1. So this gives us x squared minus x from the first bracket, then plus x minus 1. Notice that we've got a minus x plus x, so they cancel, and we're left with just two terms, and these two terms are typically square terms. And here we've got x squared minus 1. And if we look at the second example, we would have 2x times 2x plus 3 plus minus 3 times 2x plus 3. So that's 2x lots of 2x plus 3 minus 3 lots of 2x plus 3. That gives us 4x squared plus 6x, yeah, minus 6x minus 9. So really, the 6x's cancel, and we're left with just 4x squared minus 9. Example 3 is the generalization of what we've seen. So if we expand this out, we have a times a minus b, lots of b times plus b times a minus b. So a times a minus b plus b times a minus b. Therefore, we've got a squared minus ab plus ab minus b squared. Minus ab and plus ab cancel because they are nearly identical, same letters but different signs. So we're just left with a squared minus b squared. Such expressions are known as the difference of two squares. We will have a look at such expressions in a future video where we will go backwards and factorize expressions. To finish off, here are 3 examples. Feel free to have a go. Pause the video and try it. Okay, hope you've had a go. If you'd been using the formula a plus b times a minus b is identical to a squared minus b squared, or we call that an identity, you should have got x squared minus 9 for the first one. So note that this is a typo, it should have read x minus 3 times x was 3. For the second example, you would have got 9x squared minus 4. And for the final example, x squared minus a squared. Did you get them? Excellent if you did. That'll be it for this video. In the next video, we will have a look at applications of expanding double brackets. We will also be looking at expanding triple brackets in the following video. Thank you for watching this video and listening. Don't forget to subscribe, give this a thumbs up, like, turn on the notifications by hitting the bell so that you can get notified when a new video gets released, and don't forget to share this video with your friends, peers and teachers. Hope to see you again on Maths and Stats Tutor UK. Bye.